We have discussed what is screening, what are various types of screening. We have also discussed uses of screening. Then we discussed criteria for screening. In criteria, we discussed that screening test must be valid. We discussed what is sensitivity, what is specificity, what is predictive accuracy. Now we will solve few problems regarding screening. So, learning objectives of this lecture are how to draw 2 by 2 table for screening. Then we will do some calculations. In the end, we will summarize the session. Why calculations are important? Number one, cause it's a university question. It's a mandatory question in university. Then a screening test which is sensitive, which is specific, which have a predictive accuracy should be used. We calculate these values for prediction of test. Or we can say that if a test is sensitive and specific, we can use this test for screening. Otherwise, we can't use that test for screening. So let's start. Uh, I will tell you how to divide a scenario. First, we should read the scenario in a survey of 10,000 people. So, total population was 10,000. Were checked for their blood sugar levels in a community. In a community, they checked 10,000 people for their blood sugar levels. And out of 60 test positive individuals, this means total population is 10,000 and 60 were positive, or we can say that test was positive for 60 individuals. 40 had the confirmed disease. This means out of 60, only 40 had the disease or 40 were diseased. And 9,940 were negative. So we can write 9,940 as negative. But after a diagnostic test, 100 had the confirmed disease, 100 were diagnosed as diseased. So calculate sensitivity, specificity, predictive accuracy of the test. So first we will draw 2 by 2 table. There are 4 boxes in 2 by 2 table because two variables are compared. We will see who are diseased and who are non-diseased. But according to test, according to positivity and negativity of test. So A is here, B is here, C is here, and D is here. As it was mentioned that total population is 10,000, out of which 60 individuals showed positive result and remaining 9,940 were negative. Now you can calculate the total population, it is 10,000. So we can write 60 here, 60 were positive and 9,940 were negative. But after confirmatory test, it was seen that only 40 were diseased out of 60. So 40 were true positive and 20 were false positive. So we can write 20 here and 40 here. When we calculate or when we add 40 plus 20 is equal to 60. And 9,940 were negative, but after confirmatory test, 100 had the disease. Now 9,840 were true negative. When we add both of them, answer is 9,940. Remember one thing, when you add all of this, it should be equal to 10,000. When you add A and B, it should be equal to 60. And when you add C and D, it's equal to 9,940 cause we already know that if a screening test is positive, it can be true positive or false positive. And if a test is negative, it can be true negative and false negative. False positive are those who don't have the disease. They were wrongly diagnosed by a screening test. False negative means that those who are suffering from the disease, but a screening test showed that they don't have the disease. That's why we do confirmatory test to see the validity of screening test. Now, what we need to calculate? We need to calculate sensitivity, specificity, and predictive accuracy. We will calculate them one by one. Let's start with sensitivity and specificity. A test should be sensitive and it should be specific. So we will calculate sensitivity and we will calculate specificity. We know that sensitivity means percentage of true positive among diseased. So these are diseased. A and C are diseased, but true positive is A. So the formula of sensitivity will be A over A plus C, and we multiply it by 100 because we will calculate the percentage. We know from the 2 by 2 table that A is 40 and A plus C is equal to 140. So we will divide 40 with 140 and multiply it with 100. We should add A and C. This screening test is less sensitive because true positive were less than false negative. They were total diseased. Or we can say that we divide true positive with confirmed disease cases, and our answer should be 28%. What is specificity? It means percentage of true negative among negative, or we can say that percentage of true negative, these are true negative, among total non-diseased. So what was true negative? 9,840 were non-diseased and 9,860 were non-diseased, cause 20 were false positive. This means they are non-diseased. We'll multiply it by 100. Our answer will be 99%. This means this test generates more true negatives or more negatives than positives. Or we can say that this test is more specific cause it generates non-diseased more than diseased, cause sensitivity is only 28% and specificity is 99%. So this test yields negative results or this test yields non-diseased. Now we will calculate the predictive accuracy. There are two predictive accuracies, positive predictive value and we need to calculate negative predictive value. What is meant by positive predictive value? It means that percentage of true positive among total positive. 60 were positive. We need to calculate percentage of true positive among 60. 40 were true positive and 60 were total positive. So we can write the formula A over A plus B into 100. What is A? A is 40. What is A plus B? 40 plus 20, 60. Or we can say that we divide true positive with total positives and we'll multiply it by 100. What will be our answer then? Roughly 66%. This means that this test yields 66% true positives among positives, which is quite low. What is negative predictive value? It means percentage of true negative among total negatives. What were true negative? If we go back, 9,840 were true negative, but total negative were 9,940. So we'll divide 9,840, or we can write the formula D over C plus D into 100. What was D? 9,840 and C plus D 9,940, and we need to multiply this by 100. So roughly our answer will be 92%. This means that this test yields 92% true negatives. So negative accuracy of this test is more than positive accuracy. And after calculating sensitivity, we have calculated sensitivity, specificity, positive predictive value, and negative predictive value. If you see the values of all, sensitivity was 28%, specificity was 99%, positive predictive accuracy was 66%, and negative predictive value is 92%. So this test goes towards negative results, or it is yielding non-diseased. So in the end, we can interpret that this test is more sensitive, but not specific. For an ideal screening test, it should be sensitive and it should be specific. Now, we move towards next scenario, dengue fever. Nowadays, dengue is common. In a dengue fever diagnosis, 200 samples were tested. So this means that total population who was tested is 200. By kit and confirmed by ELISA, definitely. First we screen and then we confirm test by ELISA. Out of 110 samples were tested positive. This means samples which were positive was 110. By kit and 80 were confirmed by ELISA. This means out of 110, 80 were diseased or 80 were confirmed. 200 persons were screened and then 110 samples were positive, but out of 110, 80 were confirmed by ELISA that they are suffering from disease. Out of it, 70 negative samples were confirmed. Remaining population was 90. As we know that total population is 200. If 110 were positive, total negative were 90. Sometimes they don't give negative values. They just give total population and positive values or positive tests. So we can calculate negative test by subtracting total population minus those who were positive. Total population was 200 and positive were 110. So 90 tests were negative. But in the end, it said that out of it, 70 negative samples were confirmed as negative by ELISA. This means out of 90, 70 were negative. First, you should subdivide the scenario. You should take total population, you should take positive test and negative test. Then we move towards disease and non-diseased. So let's make 2 by 2 table. Sometimes scenarios are quite complicated, so you need to simplify them. The best way to simplify them is to subdivide. First are the 2 by 2 table. These are diseased, these are non-diseased, test positive and test negative. Write A, B, C, D. Then write total population 200 positive, 110. Definitely 90 are negative. So you can write positive 110 here, negative here. The scenario showed that out of 110, 80 were confirmed by ELISA. 80 were confirmed positive by ELISA. So you can write 80 here, that is true positive. Here is 30. Why 30? Because total positive were 110. 80 were true positive. Definitely remaining were false positive. If we subtract 110 with 80, answer is 30. So if we add 80 plus 30, it's equal to 110. Then it said that out of remaining 70 negative samples were confirmed as negative. This means out of 90, 70 samples were true negatives. And if we subtract, our answer will be 20. So 20 were false negative. This means that 20 were diseased, but they were identified as negative as a result of screening test. Definitely, sometimes screening test yields true false positive and true false negatives. That's why we calculate sensitivity and specificity. Now, you have drawn 2 by 2 table. If we add all of them, our answer will be 200. If we add 80 plus 30, 110 positive. If we add 20 plus 70, 90 negative. Now, we need to calculate. First, we will calculate sensitivity and then we will calculate specificity. Why we calculate them parallelly? Because sensitivity and specificity are related with each other. Sensitivity shows diseased and specificity shows non-diseased. What's the formula of sensitivity? Percentage of true positive among total disease. So total disease is 100 and 80 are true positive. We write the formula A over A plus C into 100. You must remember the formulas. A is 80, A plus C is 100, and our answer is 80%. This means that this test is 80% sensitive. Now we will move towards specificity. What is meant by specificity? Percentage of true negative among total non-disease. Total non-disease were 100. So 70 were true negative. We write the formula D over B plus D into 100. Why B plus D? These are total non-diseased or non-diseased population. What is D? 70. And B plus D is 100. Our answer will be 70%. This test yields 80% true positives and 70% true negatives. Or we can say that sensitivity is 80%. This test is 80% sensitive and 70% specific. Now we will calculate the predictive accuracy. It is positive predictive value and negative predictive value. We will see the percentage of true positive among positives. Total positive were 1000 and true positive were 80. So formula is A over A plus B into 100. How many were true positive? 80. So we divide 80 with 110 and multiply it by 100. What will be our answer? It will be roughly 72%. This test yields 72% true positive. And what is negative predictive value? You know the formula. We divide true negative with total negative and multiply it by 100. How many were true negative? 70 were true negative out of 90. Formula D divided by C plus D. D is 70. 70 were true negative and total negative were 90. We multiply it by 100. So what will be our answer? We divide 700,000 with 90. So if you calculate, it is about 77%. This means this test yields 72% true positives and 77% true negatives. So what we have calculated? We have calculated sensitivity, we have calculated specificity, we have calculated positive predictive value, we have calculated negative predictive value. Now we will analyze them. Sensitivity was 80%, specificity was 70%, positive predictive value was 72%, and negative predictive value was 77%. This test is much better than previous test because it is 80% sensitive, 70% specific. Our positive predictive accuracy is greater, negative predictive accuracy is greater. So we can use ELISA. So from this we can conclude that this test can be used as a screening test. All our screening test yields true results more or less. Ideal screening test is that which yields 100% sensitive results and 100% specific. But practically this may not be possible. So we compare which test is better. Now we will move towards other scenario. In a breast cancer screening program, 12 out of 30 with mammography test result positive were found to be suffering from the disease. 30 were positive. 12 out of 30. Remember this. 30 were positive and 12 were suffering from disease. And 16 out of 130 with mammography test negative were found to have the disease. So negative were 130. 16 were suffering from disease. You need to subdivide scenarios. This means the total population is 160. 30 were positive and 130 were negative. This is total population. Now we need to draw 2 by 2 table. We need to calculate specificity and negative predictive value of the test. Sometimes they ask specific questions like there they have asked calculate specificity, calculate negative predictive value. So first we will draw 2 by 2 table. Draw 2 columns and 2 rows in 2 by 2 table to compare two variables. One variable is disease and other variable is positivity or negativity. This is diseased, these are non-diseased, test positive and negative. This means that those who have the test positive can be diseased and can be non-diseased. Those who have shown negative results can also be diseased because screening test doesn't yield 100% result or it is not confirmatory. If you remember from the previous session, I discussed that screening test is not confirmatory. That's why we do diagnostic test. Now, 30 were positive and 130 were negative. 30 were positive and 130 were negative. Then write A, B, C, D. It is said that 12 out of 30 were diseased. How much? 12 were diseased. This means that 12 were true positive. And remaining 18 were non-diseased. Because we have to add true positive with false positive. So it should be 30. 30 were total positive results, but only 12 were diseased. This means that 80 were not having the disease. 30 yield negative results, but 16 were diseased. This means that 16 were false negative. They were having the disease, but screening test showed that they are normal. The remaining 114 were true negative because we need to add both of them. False negative with true negative. Answer should be total negative, or we can say that positive is equal to true positive plus false positive. 12 plus 18 is equal to 30. These are positive. Negative is equal to false negative plus true negative. False negative was 16, true negative was 140. Our answer should be 130. So we have confirmed that our table is right. Now we need to calculate specificity and negative predictive value. So first we will calculate specificity. What is specificity? Percentage of true negative among total non-diseased. True negative are 140. This means the formula is D over B plus D. We can write D over B plus D into 100. What was D? 114. B plus D, we need to add 1. 14 with 18. Answer should be 132. And we'll multiply it with 100. 11400 divided by 132. This is not 122, this is 132. What will be our answer? Our answer is 86%. This means that this screening test yields 86% negative results. Now we need to calculate negative predictive value. What is meant by negative predictive value? Percentage of negative, true negative among negative. D or true negative, so we will divide D with C plus D and multiply it by 100. What was D? D is 140, 14, and B plus D is 130. So we need to divide 114 with 130 and we'll multiply it by 100. Our answer is 87.69%. Don't forget to write percentage because this is percentage. This means that this screening test yields 87% true negatives. So what we have calculated? We have calculated specificity and negative predictive value. Specificity was 86%, negative predictive value is 87%. So this test or this screening test can be reliable because it yields 86% true negative and 86% true negative among non-diseased and 87% negative among total negative.